Okay, let's solve a 6 by 6 straights. There's three types of compartments you can encounter. They are black cell to black cell. They are outer edge to outer edge. And the last one is black cell to outer edge. Let's start with compartments. Let me explain to you what compartments are. Let's draw some in so you can see them. So we've got a 3 and 1 space beside it. Here's another compartment. We've got a 5 with 2 spaces. We've got a 1 here with 3 spaces. We have a 6 here with 2 spaces. Let's do a long one. So we have this 4 with a total of 5 empty spaces. So those are the three compartments you can encounter. Explain now the sequential part of the puzzle, or the straights part. This is a perfect example here. This line here, the numbers are from 1 to 6. We need 1 to 6 in this space in some form. 1, 2, 3, 4, 5, 6 would be okay. 2, 3, 1, 5, 4, 6 would be okay. So the numbers need to be all there, but they can be in any order. Let's fill in a couple of numbers together. So let's start with this compartment here. So we've got a 3. The only two numbers that could be next to a 3 are a 2 and a 4. We already have a 4 here, so this number needs to be a 2. Next rule in straights that helps us understand how to fill in these sequences is this 4 that's here may only appear once in a row and a column, so the 4 can't appear again in this space. So what that means is, as an example, we have a 3 here, so the only two numbers that can go into a compartment with a 3, so this compartment here, is a 2 and a 4. We have the 4 already. The 4 can't appear here again, so this must be a 2. Down here we have a 6 and 1 cell in the compartment with it. The only number that can go with a 6, since it's the highest number in the sequence, is a 5. This needs to be a 5. Over here is a perfect opportunity to explain the white numbers in black cells. We have a 1 and a 3 as white numbers in a black cell. That means 1 and 3 may not appear in these two spaces, and the 3 may not appear in this space. Having the 3 here means that these two cells need to be higher than 3. So the only two options we have here are 4 and 6 and 4 and 6. We already have a 4 over here, so this must be a 6. And that leaves this as a 4. Okay, so now we've filled in enough numbers to understand how the sequencing works and the straights. Okay, let's try to explain the sequence that needs not to be in numerical order with this long line here with the 6 numbers that need to go in here. We've got a 1 here and a 5, and the only number that we don't have left is a 3. So we need 1, 3, 5 in these spaces. We have a 1 and a 5 here that is precluded, so this has to be the 3. And we can fill in the notes and 5 and 1 and 5 here to help us out later down the way. So this is basically what you need to do to get through the puzzle, to get to the end of it and understand how it works. One last thing I want to explain is the black cells themselves. This black cell, you cannot try to associate a number value with that black cell. It has no value. All the black cells are not related to the puzzle, and they're not part of a sequence of the puzzle. And the same thing applies to all these numbers. They are never a part of a sequence of a straights. They are basically an eliminator. They eliminate that number as an option in the corresponding rows and columns.